Welcome to part 3 of the cross-coupled shared apex loop experiment update. It's been quite a while since my last update, and I've learned a lot since the last one and now have a 4-direction array up and running. So I'm anxious to share what I've learned, and so let's dive in. The cross-coupled shared apex loop is a cousin of the simpler shared apex loop. In this more complex configuration, signals from 2 pairs of cross-coupled loops are combined with one of the signals that are delayed relative to the other. So for this update, I'm going to cover quite a bit of new ground. First, I'll present new findings that simplify the setup and improve the performance. Then I'll describe my current array and some first impressions. And after that, let's look and demo the array in operation. We'll run from about 1.7 megahertz all the way up to 15 megahertz on various bands. And then we'll wrap up with just a quick discussion about other variations and ways to improve the performance even further. So the cross-coupled shared apex loop has a modeled RDF of about 11.5 to 11.6 dB. It makes it similar to a 900-foot beverage on 160 meters. And the takeoff angle is nicely centered at about 20 degrees above the horizon. The array is electronically rotatable using the shared apex switch combiner and controller from Array Solutions. A single delay line provides the necessary delay. Like any experiment, you often run into the unexpected. In part 1, I described an isolation transformer that seemed to improve the performance on 80 meters. At the time, I couldn't really explain why it was needed, and after more experimentation, I found that this early finding was anomalous. And so now I believe that the isolation transformer that we talked about in part 1 is no longer necessary. A more important finding comes from something that we have known for quite a while, but didn't have a practical use for it. As it turns out, the signal flowing through the adjacent vertical wire segments in a shared apex loop in the center of the loop pair are very similar. In fact, they are so similar that they can be replaced by a single conductor. So here we have 2 loops. In this case, they're rectangular. And we have the 2 wires that are parallel in the center. Watch what happens here. As it turns out, we can actually take a single loop and run a bisecting wire, a wire that runs from the center of the top to the center of the bottom, and have electrically the same situation, at least from a signal standpoint. This finding simplifies the construction because the spacing between the individual loops no longer needs to be managed. And so it makes it a much easier array to construct. Another finding is also important and was a bit surprising. In part 1 and also at Dayton, I described an initial concept for the cross-coupled shared apex loop where the cross-coupling occurred via the adjacent loops, and the couplers were located near the center, as shown in the diagram. However, from modeling, I found that there is another method to cross-couple within the array, and this other method has some distinct advantages. This method cross-couples the alternate loops rather than the adjacent loops, and positions the couplers on the corners. Although the couplers could be spaced in the middle, it just turns out that on the corners you actually get additional gain. So cross-coupling using this alternating method provides about 10 decibels more forward gain, a shorter delay line, and a wider directional bandwidth. Very, very helpful advantages. I also found that using Cat5 cable provides a readily available and convenient way to feed the array. even when using the alternating cross-coupling method. The Cat5 cable has 4 twisted pairs, but we use only 2 of the 4 pairs in each cable as shown in the diagram. Once again, this is a simplification where it simplifies, in this case, the signal or cable routing, but I have only tested it on my 40 feet diameter array. So further testing needs to be done to see how it will act on longer and larger arrays. You know, sometimes you have to learn things the old-fashioned way by making mistakes. My first 4-direction array was based on the current source models in 4NEC2. And those models taught that there wasn't a need to have much space in the middle of the array between the loops, the bisected loops. Unfortunately, after I built that array, I was very underwhelmed by the performance. What I saw was that the front to side was not what I expected, and I also found that the delay timing was inconsistent. The array seemed to need longer delay lines for lower frequencies. One of the things that I have appreciated about the shared apex and certainly the modeling has taught on the cross-coupled shared apex is the wide directional bandwidth, so that you can operate multiple bands with a single delay line. Well, the first array that I constructed, the first 4-direction array, did not have those characteristics, and that was very disappointing. It seemed that the array was actually slower as the frequency decreased, and this seemed to me to be a symptom of interaction between the loops. In looking at the model, I went and questioned that assumption that I had made about using current sources and replaced the current sources with voltage sources. And what I found was that the voltage source actually taught that we needed to have a distance in the middle, and when I went ahead and modified my initial array to include that distance, all of a sudden everything started working as expected. So the voltage source model teaches that this distance, we'll call it D, should be at least equal to, and this is just an estimate, we're still learning here, but we'll say for right now, at least equal to the height of the loop within the array to maintain a consistent delay. As I said, the current source model does not teach this. So if your loop height is 20 feet, then I would recommend having 20 feet distance in the middle of that array. If it's 30 feet, 30 feet, etc. Another finding that the cross-coupled shared apex loop requires careful dimensional accuracy for optimum performance. The lower the frequency, the more critical this accuracy. So it is important to pay attention to the details. So for instance, each half loop must have the same area and be as close to the same shape as possible for optimum results. I also found it helpful to measure and mark the loop tether points and secure them with a wire tie to hold in the position as shown in the picture. So I basically just took a Sharpie and pre-measured all of the loops, and not only measured the wire length but also marked the wire itself with a Sharpie, indicating where the bend needed to be made on the loop, and then took a wire tie and actually just tied it over, forcing that bend on the wire, and then the rope just hooked in to where that bend was, and that was held in place by the wire tie. And so far, it's only been up a couple of months, but that seems to be holding, and it certainly is holding the position of those loop corners, which is very desirable. Another finding is that we were able to use the 4 primary directions using the array solution shared apex electronics. This was expected. each of these primary directions is oriented along the plane of each group. But I also found that there are two useful hybrid directions, which are combinations of the two primary directions as shown. So in this case, the east and the west are useful hybrid directions. For example, the west pattern is the sum of the northwest and southwest patterns. The east and west hybrids have a good front to back, but they have a wider beam width than their primary counterparts. So the RDF is a little bit lower, but they're still useful because of that good front to back. The other two hybrid directions, in this case the north and the south, are not very useful. For example, the south pattern is formed by the difference between the southwest and the southeast patterns. The north and south hybrids have frontal nulls in their respective directions and then 45-degree side lobes. So they're really not that useful. Okay, that was a lot of material to cover. It should get a little easier from here on. So here's a photo of my experimental array. This array is smaller than what most people will need, but it has been very useful for proving out the models. We'll talk about scaling it up a bit later at the end of this discussion. The array solution shared apex switch combiner is located at the base of the middle pole, and the Cat5 cables are used to bring the signals from the loops to the switch combiner that's located in the middle. So the northeast loop is shown in red, and there is the southwest loop, and there is the northwest and the southeast. So that gives you an array of, or an idea of what the array actually looks like. And my array fits within a 40-foot diameter, as shown in the plan view, and will fit in a 29-foot by 29-foot square area. Okay, let's take a closer look at the northeast and southwest loop pair to gain an appreciation for the details. Notice that the loops are generally rectangular in shape, with a bisecting wire in the middle. The bisecting wire is purposely made to be shorter than the loop sides so that all the wires can be held in tension, so that the shape of the loop is dictated by its wire lengths. Now for my small test array, I used the dimensions shown to form bisected loops that are 12 feet tall and 12 feet wide. The loops are suspended by rope that is supported by 16-foot fiberglass poles. There is 12 feet of spacing in the middle of the array and 2 feet between the edge of each loop and the outer support poles. All right, the couplers are positioned on the outside edges of the loops. The northeast cross-coupled pair is connected to the switch combiner as shown, so that signals from each loop are subtracted since they are connected in opposite phase. This subtraction forms a bidirectional pattern with nulls off to the sides and a deep null off to the top. The resultant signal becomes available at the northeast terminals for further processing in the switch combiner. The southwest cross-coupled pair is coupled and connected to the switch combiner in a similar manner. The southeast and northwest loops also follow a similar pattern. In the switch combiner, the signals from the favored direction cross-coupled pair are routed directly to the internal combiner, while signals from the opposite direction cross-coupled pair are routed through a 12-foot delay line and then to the internal combiner, where the signals are then amplified and sent to the controller located in the shack. This delay line sets the timing, which is essential for achieving good front-to-back ratio. So the 4NEC2 model predicts the horizontal and elevation total gain patterns for 160 meters, and there's 80 meters, and 40 meters, and 30 meters, and finally 20 meters. So you can see the wide directional bandwidth that the cross-coupled shared apex loop enjoys. So now the array is built and I've been using it for a few months. Here's some first impressions. The first is the sensitivity at this scale is similar to the SAL 12. It really needs to be taller and wider to improve the sensitivity. I also found that the front to side and front to back on signals coming from one of the primary directions, that is the northeast, southwest, southeast, and northwest, show the best correlation to the modeled performance. The 4NEC2 model does accurately predict the optimum delay time, which sets the delay line length. And the cross-coupled shared apex loop is definitely more prone to interaction than a simple shared apex loop. My house is located about 25 feet from the northwest edge of the array, and the northwest-southeast pattern is clearly degraded on frequencies below 1500 kilohertz. And one-to-one couplers for this size of the array provide better sensitivity below about 3.5 megahertz. 4-to-1 couplers are better above 3.5 megahertz. So enough of the theory and the details. How does it sound on the air? So my QTH is a suburban neighborhood with QR Nancy from power lines in several directions. And I'm located in southeastern Washington state. In the videos, the cross-coupled shared apex loop is connected when an antenna selector toggle switch is in the up position. And then a reference antenna is connected when the antenna selector toggle switch is in the down position. The reference antenna is a 40-meter inverted V with an apex height of about 35 feet. I will note that the S meter on the Icon 735 seems to be reasonably accurate above S9, but it's not very accurate below S9. And the videos are representative of the performance. Sometimes the performance is better than these videos, other times not as much. So here we go.
You're well, and I am. Seems like all you do is promote psychoanalysis. And while I really enjoy I've got to think it doesn't leave you much time for anything else. CC-SAL, sincerely, Miranda Morgan.
Attica, just a tap away on the Geico.
Phone insurance. Save the square trade phone protection instead. Phone insurance from Verizon, Sprint, or other wireless carriers. Square trade phone protection is only $5.
Minutes. Coordinate.
see. We might play another one. We've done a little bit of listening around, and I'll here's something real way in place. Kind of jump in and see if I can grab a content. A little bit of fun, but over the hill back and forth.
As it is, I don't remember, tell you the truth. It's just, I think it's roughly 137 feet long, 134 feet long, something like that. Go ahead.
Okay, well that's probably why you're having problems loading it up on 160 meters, because it's not long enough. But I was going to say, you could always, if you have it up quite a ways, well, that'd be a lot of wire to hang down, wouldn't it? Anyway, yeah, if it works, if the antenna works on 75 meters and up, then I do like off-center. I just think they're really, really good antennas, and that's what I'm using. It has been for like many, many years, like 10 years or something. I've had the same antenna.
A Clube na madrugada.
Minutes, coordinated universal.
At the tone, 5 hours, 2 minutes, coordinated universal time.
If you want to go a step beyond the X-beam, have a more versatile and give you better performance, more expensive. But it is a wideband antenna. You could use the right period. Band 8, 10, and 12 6, 8, 10, and 12 element periodic. Other companies make them as well. I think M Square makes one. KLM used to make them. I'm not sure if they do. And then there are, of course, you can find military surplus log periodic antennas. If you're lucky, you can find them in the surplus market at very reasonable prices. Outfits such as Fair Radio in Lima, Ohio, make them. And you can assemble the antenna and put it up on a mast. It's a rotatable antenna. It has the advantages of the 7-hour in terms of broadband, without the disadvantages in the sense that it doesn't have any moving parts. It doesn't have the gain. It doesn't have the load, but it doesn't have any moving parts to play with. So, a commercial HF operator.
Kancana Katina, Kion Seminario Segunas, Intia Mario Masunpata Paishin, Secretary Serial, Colonia Misan, Lina que lo funcionar y para el que la basta democrática.
الفائدة التي أردت بها عندي انتماء أعزاء في كان سبعة ومحمد السيد عبد الرحيم والهاوي السيد وعبد الرحمن الحسن ولطف حنان عثمان والأستاذ والأديب محمد عبد الباقي وكمان بالعمارة من الجزائر يقف على رأس جامعة الجماعة العامة عادل الشرقاوي وعبد الله المسير وأيضا الجزائر الأوزاع من المغرب عبد الرحيم آية
ناشطون في مجال العمل الفضائي ومنشئين عمل أصبحت
Venezuela no habla de escasez, sino de una situación que radica en el problema contractual en el puerto de Los Ángeles y los Estados Unidos. He says young people need to learn the proper in order to be able to knit them. But teach the kids in a flower garden school how to wrap them and to whether they're right. Well, that's another story.
Now, even if you don't have many times during my trips to Taito, and this year I'd heard that the Jupe, who I call Jupe Ai, that means inspiration. Where did the inspiration came from and what was inside?
因为我们有送了算是很不错的牛肉，还有很不错的虾。A friend gave me some high quality beef and some sauce. Los grupos extremistas armados y la situación política y económica regional. Gobernantes de los 54 países y miembros de la organización discutirán además en Addis Abeba nuevas acciones para el apoderamiento y desarrollo de la mujer hacia la Agenda de África 2063 y revisarán los resultados del trabajo 2014. En la jornada de este viernes se prevé la intervención ante el plenario de los secretarios generales de la ONU, Ban Ki-moon, y de la Liga Árabe.
So hopefully those videos give you a good idea of the real-world performance of the cross-coupled shared apex loop. As I said before, though most of you will want to make this array larger to improve the sensitivity on the low bands. For example, an array with a diameter of 60 feet that has 20-foot tall loops should provide nearly as much forward gain as an SAL 30. You know, the things that we have learned with this smaller array should apply to larger arrays as well. I'll post a 4NEC2 model on the Yahoo Shared Apex Loop users group that you can download to try other dimensions to see what works at your QTH. There are also some other ways to make a cross-coupled shared apex loop. For example, the model teaches that we can go back to our triangular loops and use the alternating feed method to achieve some interesting results. Notice the size of these loops. They're relatively small, but the gain is achieved by spacing the pairs apart. This might be a nice configuration for someone with a lot of trees. Also notice the RDF and gain figures in the table for the various bands. And there are still some other possibilities. The next two examples are theoretical, but they might be interesting to discuss in the future. For example, what happens if you put 4 pairs in a line? The model teaches here an even higher RDF. And for the overachievers in our midst, the model also teaches that a 14.3 dB RDF can be achieved by a pair of cross-coupled shared apex loops separated by a significant distance. In this case, it's about 400 feet on 160 meters. But that is an interesting looking pattern. So all these methods that I just showed you still use only a single delay line and the shared apex electronics. So as you can see, there's still lots of things to play with, but that's about all the time we have today. So I'll be posting, as I said, the 4NEC2 models on the website. I encourage you to experiment. And if this topic is interesting to you, please join the Shared Apex Loop Yahoo group. Of course, special thanks again to Array Solutions for their support in this adventure. And 73, happy DXing.